All right, so let's talk about vectors. Vectors are the fundamental data type or data structure within R. And we will use vectors all over the place, all the time within R. All right, so what is a vector? A vector is, it's one-dimensional, and it needs to hold homogeneous data types. What does that mean? Well, within R, we have many different data types. We have integers, such as 2. We have what we call double floating points, or decimals, like 2.5. We have character strings, such as something that's in quotes. And we even have logical, like true, false. And we're going to talk about all these different data types in the next module. But the main thing to realize is when we create a vector, that the vector must contain all of the same data type. Right? So you must have all integers, or all character strings, or all double floating points within that vector. You can't have a combination of data types. All right? So the thing is, if you try to combine non-homogeneous types, then we get what's called coercion. Okay? So here's an example. Say we want to create a vector. So I'm going to here's a numeric vector. And this is going to be, let me move my cursor here. This is going to be made up of integers, 1, 2, 4, and 8, right? So if we look at num vector, we see we have those values. Now, if I were to try to combine this with, let's say, a character, then what happens is that vector, all those other integer elements get coerced to characters, right? And how these things get coerced, you'll just come familiar with it. So basically, the least strict data type gets coerced to another data type. And we'll go through that in future lessons. So don't worry about that, but just realize that a vector needs to have all of the same data types, and if you combine them, then things can happen where you may get unexpected coercion, where one data type gets changed to some other dominant data type, such as a character string. All right, so like I said before, we'll use vectors all over the place. For example, here's some code. You don't know right now what this is doing, and that's fine. But in here, we're using a vector right here for filtering purposes. Here, we are using a vector, and that's what this is right here, to rename the variables within this, what we call a data frame. And right here, what we're doing is we're actually pulling out a vector of values to compute the mean. Right? So we use vectors all over the place. So it's very important to become familiar and comfortable with working with vectors. All right, so let's talk about accessing a specific element within a vector, right? So here, right, letters, you see this letters here. This is actually a built-in vector within R, and it's got all the letters of the alphabet. So this vector that I'm creating right here, let me come down, run this code. Here, all we've done is taken the first 10 letters within the alphabet. So V represents these character values. So say we wanted to access a certain value. For example, say we wanted to get out this first element, the A, right? So to do that, we use this bracket notation, right? So here I just say, I want to get the first element. Now, R is not a zero-based index. So if you're used to maybe Python, this will take you a little bit to get comfortable with. R starts at the index value of 1. So the first element is 1 and not 0. And if you haven't worked with programming languages before, it's very common to have what we call zero-based indexing. R is not one of those, right? So we can index an individual element with these brackets here. Or we could index, let's say we want to get the 1st, 5th, and 10th. So we actually supply this in a vector. And this vector right here, this C function is called like concatenate or combine. And we're creating a vector with the values 1, 5, and 10. So we can actually index V for the 1st, the 5th, and the 10th element, which we get A, E, J back. And we can even negate that. So we could say get all elements other than, so here we have this minus sign, other than the 1st, the 5th, and the 10th. And we get that in return. Now, we can even do more things, and we can do logical expressions, basically to index our vectors. So say we wanted to, here's a vector we have. Let me get to this in our script for today's lesson. Here, the number vec is numbers 1 through 10. But say we wanted to get or identify those elements in this vector that are greater than 5, right? We can do that with this greater than sign here. And we're saying, tell me which elements in numVec are greater than 5. When I run this, see I get false, 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 and then we get true for those values of 6, 7, 8, 9, and 10. Right? Well, what we can actually do is use this output, use this logical expression output to index. So here, in this line of code right here, what I am saying is I want to get all those elements from numVec that are greater than 5. And when I do that, I get 6, 7, 8, 9, and 10. So when we index with a logical expression, R will take those where the value is true, and it will extract those values for you. All right, and we can do a combination. Right, so here on the slide, you say get those where vector is greater than 2 and less than 6. Or here we have get those values or those elements where less than 2 or greater than 6. So we can do combinations of these different logical expressions. All right, so let's go ahead, pause the video, and I want you to work through these your turns. You're going to create a vector using that C function, that concatenate function. And I want you to go ahead, and this is basically representing 10, these 10 values represent the weight of kids. So just say there's some medical experiment going on. We're measuring 10 children. And so we're going to create a vector of those 10 children. And then I want you to go ahead and work through numbers 2, 3, and 4. All right, so you can see here, we created this vector of those weights. And now number 2 is, let's go ahead and extract the first and last child. Well, we have 10 children, so I want to get the first and the 10th. And so we can see we get 75 and 99. Here I get the first 5 children. In this 1 and then colon 5, this is a handy function when we want to create a sequence. And this will actually create a vector of the values 1 all the way through 5. Right? So we could always do 1 through 10. And we can even go down, right? I could say 10 colon 1, and it's going to count down from 10 to 1 in those integer values. And then I could, number 4 is extract the weights of those children that weigh over 90 pounds, right? So this is where I use that conditional expression. All right, so if we want to replace elements, we just build on to this idea of indexing, right? So we can index with the square brackets. So here's our vector of weights right here. And if I run this code here, now what I could do is say, hey, look, I want to get the 5th element. So the 5th element is this 101. And if I use the bracket notation here on the right in my RStudio, you can see I can extract that 101. But here what I'm doing is I'm going to say, well, access that 5th location, but I want to assign to it the value 100. So when I do that and then I rerun weight, we see that our 5th location has changed from 101 and it's been replaced with the value 100. And we can even do this where, say we want to take all of those elements where the weight is less than 80 pounds. right? So here, this weight less than 80 identifies all those where the weight is less than 80 pounds. And wherever it's true, here I'm saying access those elements where that's true and reassign those values 80. And so now we see where everything where we had like 75 here, 79 here, and 70 here, those have been replaced with the values 80. So that's how we can actually use logical expressions to change any number of elements that meet that condition. All right, so vectors have a lot of, there's a lot of built-in functions within R that automatically work on vectors, right? So say we have a number of temperature readings here, right? So here's a vector of some numeric values, right? There's built-in functions such as the mean, that's going to compute the mean of this vector. I can get the variance with var. I can get the standard deviation with SD. I can get the number of elements or the length of that vector with the length function. And I can even sort that, and by default it'll sort from, or basically in ascending order. Right. I could, if I wanted to sort in descending order, well then sort actually has, you can see this, it pops up, decreasing equals false, so by default it is in ascending order. But I could go ahead and I could say decreasing equals true. And now it's going to sort that vector in decreasing order. All right, so remember in a previous lesson we learned about missing values and that they're represented by NA, which means not available. So say we have a vector here where we have numeric values, but then we have these NAs sprinkled in there, okay? Well, what happens now is when I do a lot of these built-in functions, such as computing the mean or the standard deviation or the variance, then what happens in return, I get NA, right? Because we can't compute the mean when we have a value in here that we are uncertain of what that is. So what we need to do is remove those NAs and then compute the mean. And so a lot of these built-in functions, such as the mean, standard deviation, variance, the sum, and so on, they have an argument in there that is na.rm. And by default, it's set to false, and that means remove NAs. But if we set it to true, then now we see that mean behind the scenes will filter out those NAs and then compute the mean for those remaining values that exist. All right, so what I want you to do, I want you to go ahead and pause the video, work through these. You're going to create a new vector that has these weights, but notice that we have an NA value within this recording. So apparently there was maybe a child didn't show up to get recorded, or maybe the device that took the measurement didn't work for that child, and so we have a missing value in there. Now I want you to go ahead and now compute the min, the max, the mean, and the median, and the standard deviation of those weights. And then I also want you to apply the summary function, right? So for number 2, I want you to get these functions to work even though we have a missing value. And then check out and see what the summary function provides. All right, so here we see the solution. We have our weights, which includes this NA. And to compute the min, the max, and all these, the mean, the median, standard deviation, you would have to remember to include the na.rm equals true in order to get the computation to work. Now the summary function is handy. The summary function will return the min, the max, the first quartile, the median, the mean, and the third quartile for that vector, right? So you can kind of get an idea of the distribution of values within the vector. But also, if we scroll over here, you see that it will list the number of missing values within that vector. All right, so let's talk about the idea of vectorization. So many R functions operate over each element in entire vectors without requiring for loops. So in a lot of languages, if you have a vector of multiple values, to iterate over and do some computation on each element, you would have to do like a for loop. Well, R is designed where a lot of the functions are vectorized. And that just means we have functions that will automatically iterate over each element and do some computation. For example, here I have a vector that contains two elements. All right, let me go ahead and run this code. My name has two elements in their character strings, and it's my first name and my last name. All right, so if we looked at length of my name, we'd see we have two elements in there. Well, if I wanted to get the number of characters, there is a built-in function in R called nchar, and that computes the number of characters in each element. It will iterate over each element, in this case both elements within my name, and tell me how many characters are in that character string. Right, so this is the idea of vectorization. A function automatically iterates over each element and does some computation. And the nice thing is we can do basic math with this. So we previously had our weight, our vector that had the weights. Well, let's say you wanted to multiply each element by 2.2, right? We could do that. And all we need to do is basic math here. Take our vector times 2.2, and what we'll do is iterate over each element in that vector and multiply it by 2.2. Now this vector had an NA value, so you see that we get an NA in return for that element where we tried to do some multiplication. Right? And we can even do what's called vector-vector math. That's where we have two vectors. In this case, both the vectors are the same length, right? And we wanted to add them. So say we had your quiz scores, right, for this course. And let's say you were taking another course, right? You could get your quiz scores for all, I don't know how many, let's see how many quizzes you've done here. All right, so 9. You've taken 9 quizzes in 2 courses, right? You take your scores for course 1, your scores for course 2, right? And then you could add them together to kind of see what your total scores are across. And so it will iterate element, and it will do element by element, the corresponding element in each vector, and add those values together. Now, one thing to realize is that R will recycle values. So if you try to do this vector-to-vector math, but you have one vector that is shorter than the other, R will actually recycle the values and do computation. All right? So here we have a vector that is the values 1 to 10. So long is a vector of 1 to 10. Short is a vector of 1 to 5. Now, when we add these together, what will happen is we'll add long and short, and it'll go element 1 plus element 1, and then it'll go and do element 2 plus element 2. But what will happen is after you get to element 5, where we added 5 and 5 in it, now we'll get to element 6 in long, and R will recycle and go back to element 1 in short, right? So it will recycle until it completes that computation. Why is that important? Well, if you actually have a vector that is shorter than the other, and you do this where they're not a multiple of one another, you're going to get this warning, because R is going to say, hey, look, I don't know if you meant to do this, but what you're actually doing is you are recycling a shorter vector to do this computation, and it's not of equal length, so it may not be what you intended. All right, let's go ahead and pause the video, and I want you to work through this your turn, where you're creating a certain vector, and then you're going to do some vectorization computations with that vector. All right, so here are the results. You created the vector 1 through 10. First one was just to add 1, to each element, right? So you just take that vector you created and you add 1. Next one was to divide every element. Well, you can just take that vector and divide it by 2. And the last one was to create a second vector, which was values 10 to 18, and add my vec to my vec2. Now this works, this computes, but notice that there is a shorter vector, right? So the first vector has 10 values. The second vector has 8 values. So one vector is shorter than the other one, so we get a warning when we actually do that computation. All right, so that's it for right now for vectors. Don't worry, we're going to end up doing a lot of work with vectors, so a lot of this stuff will probably sink in over time. But the main things to take away: vectors are the most common data structure that you're going to use within R, and we will use them all over the place. 2, all elements within a vector need to be the same type. We're going to talk about data types in the next module, but for right now, just realize that a vector needs to be of a single data type, either all integers, all decimals, or all character strings. The most common way that we create vectors is to use the C function to combine elements together to create a vector. And then we can index individual elements or multiple elements out of a vector using bracket notation. And there's a lot of built-in operators within R to do some basic math on vectors, such as compute the mean, compute the max, the standard deviation, the sum, the median, the variance, and so on. Now, if your vector has a missing value, you need to be sure that you include na.rm equals true so that you remove those missing values before you do the computation. Otherwise, you will get na in return. All right, so that's that. If you got any questions, one, take a look at the reading for this lesson. And then if you still have additional questions, hit up the discussion board in Canvas.